natural disaster which is very common in the monsoon and the hilly region is the slope instability. I just want to give you an introduction what we have discussed in the class. Basically, what we look at is an overview. Slope failure is one of the most important types of failure in geotechnical engineering, and you hear all the time people affected. Compared to other types of failure, slope failure generally are catastrophic. It happens so fast, many times you won't get time and people may die, vehicles will get kind of lost or carried away. This is one of the most famous ones. You probably know that Alaknanda River is coming here at Vishnuprayag, and there were a lot of failures in the Garhwal Himalayas, many landslides here. You can see all of them because Himalayas are relatively geologically young, and you will find these slope failures blocking the river Alaknanda. And here is the Dhauli Ganga, they join here. And of course later it becomes Bhagirathi. And this is what happened at Patal Ganga junction. One river coming from here, and they blocked the river for some time. So they had to blast it so that there will be no dam burst. Then if you go to, as we go towards Badrinath, this Kalyasur landslide, you can see this is the road. And this landslide washed away the road, so people could not go to Badrinath crossing the Kalyasur. And this is how, if you are a pilgrim, you have to climb over the mountain, catch the other side, walking a distance of 2 kilometers on a very precarious narrow ledge. This is another slide in Garhwal Himalayas. We call it Lakwat slide. A piece of rock from here, another piece of rock. It's like a triangular piece, it fell off. So this is a block kind of failure. This is one of the biggest tragedies that happened in Kumaon Hills, Malpa tragedy on 17th August 1978. You probably would know this lady, Pratima Bedi, was a famous dancer. There were some 115 pilgrims. They were going to Kailas Manas Sarovar. They camped on the river here on the night on the way to Kailas Manas Sarovar. It rained heavily on 16th and 17th August, and this whole hill slope over a height of 1.5 kilometers, it just slipped and then killed all the 115 pilgrims and probably another 150 Sherpas who were helping them. There is a river called Kali. This was a very high, vertical, also very steep slope. There very heavy rainfall was there. So what was, you thought this was the kind of village and camp. Next day, this is what happened. The whole thing got covered with mud. This is the Meli Joratang slide. The whole area is slid, and here is our highway. Again, one of the major border roads that goes to Nathula Pass. This is another landslide in Jawaharlal Nehru Road, East Sikkim. You can see this is what is the major problem in all our Himalayan border roads, etc. This is another very interesting Kalyasur landslide over different periods of time. 2007, 2008, 9, 10, etc. And you know, it's a continuous process. What they try to do is clear this slide, and it's very expensive to stabilize these. Imagine this is about 500 meters or 300 meters high, and you can't climb up even there. So the border roads, Central Road Research Institute, others, they try to stabilize locally only by clearing the slide material and creating a road. So these are some of those failures. Again, a large mass. And sometimes you find if you don't design, even our reinforced earth walls, retaining walls will fail. This is one such retaining wall near Calcutta. So what you find here is the kind of failures. So there was a slope here. Because you want to go in the mountains, you cut it. So what you do is remove the material, put it here, but you are never sure that this can be stable. So unless you spend a lot of money and do that, you can have a lot of failures of this kind. This is a planar failure. This is some kind of flow. A large area slips and flows along this. So you have different types of failure that are possible. And here is the kind of thing. Soil here lost support, so it falls down, and this part of the soil or rock loses support, it starts falling down too. And here you can see the block sliding. These are all the rock failures that are possible, and if you go on the Bombay-Pune Expressway, you will find that. So type of failures are, in case of rock, we call it as rock falls. A toppling, when you have a high block rotates. Then you can have slides, a rotational slide, a translational slide, or it will just spread like a kind of flood, it will go around. Sometimes the soil becomes so soft, it can also flow, particularly under heavy rain. And these are the other kind of slopes failures in soil. You have a circular failure. This is a non-circular failure. If you have this is infinite slope, so you have a translational failure along this. This is what is called as a compound arc of a circle, planar, and another arc here, because you have a hard surface. This failure surface cannot go into the hard area, so it flows along the interface between the two. Creep occasionally occurs, particularly in the Himachal Pradesh area. The soil moves very slowly, and you can see that if you find the trees are not vertical but they are inclined, it means the ground is creeping, and you get creep as a one slow process. These are the different types of slides that we were talking. A circular one, this is a shallow one, non-circular. This could be a fall, compound one, block slides. This part is stable for the time being, and then this is trying to slide down. So you find all possible failure modes in nature. Then it's a sequential one. This is called retrogressive. First, a slide will take place. So the soil here lost support. It will start sliding. So first slide, second, third, fourth. You can again see this very commonly in the Himalayas. Slumps are when the soil kind of just drops down without sliding, and these are the slump kind of rotational failures. And if you build an embankment on soft clay, like Konkan Railway or New Bombay, or even, for example, in Visakhapatnam, etc., you have very soft clay, you build an embankment, the possibility of such failure is very common. So then you can have block failures. It will slide along this weak soil surface. If you have a thin seam, it will go here and move. So these are other possible failure modes that we have. So in order to study slope stability, we define factor of safety, and we always talk of limit equilibrium. What will be the equilibrium when the activating forces and the resisting forces are just about equal? Then you can say factor of safety is the resisting force or moment divided by driving force or moment, or I can say strength by the shear stress causing sliding. So we can talk in terms of forces or stresses. We take always a ratio of resisting to driving forces. So for example, if I take a point here, the strength is undrained strength, and what is the force that causes sliding? So we can do that for purely coarse soils or in terms of total stresses. In terms of effective stresses, I say C prime plus sigma prime tan phi by this is the force required to keep it in equilibrium, and so we take the factor of safety in terms of stresses. This is the planar failure surface. Basically what we'll talk again, weight, the normal force, and the resisting force. So summation of resisting forces, C, summation of mobilizing forces which are causing sliding, give me factor of safety. In case of rotation, we say take the moment of this force W with respect to the center, so W into X is the activating force, it's causing sliding along this, whereas this strength mobilized along the base, so undrained strength, I integrate over this length, and you know the lever arm is always equal to R, so R into integral SU into ds gives me the resisting moment. You take the factor of safety. Now we need to worry about, if I know the stresses, port pressures, etc., we can do with effective stress analysis. If I do not know the port pressures, I'll have to use total stress analysis. We normally prefer to do an effective stress analysis, and critical surface has to be found out by choosing a number of trial circles and find out which is the most critical one.